Hello and welcome to another tutorial. So this is the next part of the AI series focused on the hybrid goal-oriented action planning or GOAP system. So previously what we had looked at was getting the basics of our idle and wander actions going. This time around we're going to be focusing on getting the chase action happening, which means we're going to be integrating with sensor information as well. We're also going to be getting things up and running for being able to take a look at points of interest. So that's going to be the focus of what we get up and running first. So as with all of the other parts of this series, in the description you will find 3 links to different stages of the code. The first link is going to be the code as it is currently for starting this tutorial. The second link will be the code as it is at the end of the tutorial. And the final link will be to the completed AI package that you can use via the Unity Package Manager. So all of those are available for you to access. So let's dive on in. So I said we wanted to get up and running support for the chase behaviors and things like that. So what we did last time was we had a very basic version of the AI going. And I'm going to actually create a prefab. So we'll have a prefabs folder. And this is in our examples section. So this will be the base prefab. Then what I'm going to do is I'm going to actually have modified versions for kind of the different test scenes. So I'm going to, in this case, switch over to the first person test scene. So this is the one where I'll be doing the actual chasing logic. So we can save the RTS one. So what I'm going to do is I'm going to bring in this prefab. I will rename it. So this will be FPS variant. And I will just bring this down here and specifically as a prefab variant because there is going to be some specific customization for it. So our starting point is I want to set up our goal and our action. So we're going to have a GOAP goal for chase. And we're going to have a GOAP action also for chase. So we'll have a GOAP action, chase. So that's a couple of the core bits that we need. And we're going to open those up and start configuring those. So do our usual setup that we were doing of clearing out the bits that we don't need. Like that. So in terms of the actual chase goal, well, we're going to make sure that this is based off of our GOAP goal base. That obviously means there's a couple of functions we need to implement. So, okay, with this is one of the ones where I actually want there to be a variation in the priority for actually chasing the target. So what I'm going to do is have a serialize field, and there will be an int, and this is going to be a desire to chase start distance. So that's the distance at which that desire to chase is going to kick in. And we're going to say that that kicks in at 1 meter. Then there is going to be a maximum distance. So this is the distance where the desire to chase is basically runs out. So the desire to chase, we could call this the end distance. So anything beyond that, we don't actually want to be chasing the character. So, okay, good so far. Now the priority here, I want to be calculating that and having it vary. So I need to get the location of my target though. So that's pretty straightforward for me being able to do. What I'm going to set up here is a vector3 get target location. And what this is going to do is, okay, well, our target location, I'm going to initially set that to our invalid vector3 position. Then I want to try and retrieve that from the Blackboard. So we might have a target game object, or we might have an actual target position. So these are going to be configured in a very base common set of names. So we don't have target stuff configured at the moment, but what I'm going to do is get that set up. So what I'll have is, I'm just going to use these as a basis. So we've got current location, things like that. I want to have a target, and then I want to have a couple of things here. One, we might have a target that is a game object. We also might have a target that is only defined as a position. So that's going to be target game object of target and position. So these are ones that in our base brain, I actually want to configure those. So we'll go to brain wrapper. Be the easiest way to head there because we're already doing a bunch of configuration of some Blackboard ones here. So I'm going to do a similar thing. So we're going to set our target game object. Now this, I want it to be null, but that will get a little bit confused of not knowing which thing it should actually be running. So although it's null, we can actually still do a cast to game object, and then it will know that I'm trying to set a game object to that value. And then for the position, it's able to infer the type correctly there. So that's good. We know that they will be initialized to a safe value. So that's good. So we can go back to our chase goal. And what we can do in the chase goal is we can actually, firstly, we would look to see, have we got a target game object? So we'd attempt to get the target object. So we could do a game object target geo is null, and we could say, okay, well, our linked Blackboard, and we want to try get common core names and our target game object, and we out to the target game object. So if it successfully retrieved it, then we still need to check if it's null. So this is actually what I would do, is I wouldn't even bother checking the return value. I'll just make the default null and not even test it, because we still want to null check it, because try get there is going to succeed as long as that key is present. So if the target game object is not equal to null, then our target location is our target game objects transform position. Otherwise, what we would do is we would say linked Blackboard try get. Now this will be fairly similar, but in this case we try the position, and if we can, we'll output that to target location, but we provide a default value of our invalid vector3. And then we can just return target location. So that works. That allows us to retrieve where we're currently, trying to target. So in the prepare for planning here, I would say, okay, well, vector 3 target location is getting our target location. And then I could say, okay, well, if that target location is invalid, so if it's our common core constants and our invalid vector 3, then all we would do is priority is do not run. Otherwise, we actually need to calculate it. Now, in order to calculate it, I need to know the distance that we are from it. Well, I can get my current location because I can say, well, current location is our linked Blackboard, and we retrieve. Now, this is something where we know that this is going to be populated because this is something we continually update. So our current location, so that's good. So we can calculate our distance to that particular location. So distance to target squared, because if we don't need to square root it, we want to try and avoid that. So what we can do is we can say, okay, well, current minus target and square magnitude. So if our distance to target squared is greater than our n distance multiplied by the other distance, so we just have that squared. So if it's beyond the end range, then that's quite easy. Our priority is do not run. Otherwise, the other scenario we could have is that it is less than desire to chase start distance squared, in which case the priority actually is going to be our goal priority, and we would say high. And then the final scenario, we know it must be between those two. I'll just make sure that didn't bring in a using, it didn't. So now we know that we can interpolate it, and that's sort of going to be the goal there, is to then interpolate what that priority should actually be. So we'll just fix up the error because we just missed an F. So then we've got our final case here. So we need to figure out our interpolation factor. So our interpolation factor, that's going to be, we do a mathf inverse loop. We give it our start distance, our desire to chase end distance, and the actual distance that we are at, which for that we would do a mathf square root of our distance to target squared. So it gives us our interpolation factor. So then our priority becomes, we'll do a floor to int. Now we use our GOAP, we then actually, do a loop from, we would say our goal priority high to goal priority low by the interpolation factor. That just means that the chase priority can vary from low to high, and the closer we are, so this inverse loop is going to mean that that's our start, that's our end, and the distance in between. So it's going to be a lower priority the further away they are. So that works well for figuring out the priority for this. Just make sure Unity's happy, which it is. So that's good. So that's that one set up. So then in terms of what the action does, the action is not too ridiculous, but it does actually have some changes that we'll need to make to some of our other systems, which is fine. So we have our GOAP action base. Obviously, there's a bunch of things we need to implement. So this is going to be doing navigation related stuff. So that does mean similar to what we had for Wander, which to make it consistent, I will actually use these exact ones here from Wander. So we want those. So we're going to have a couple of things that are pretty straightforward. Now the cost, I'm going to just always have that be a fixed cost, because our distance is constantly going to be changing. Having a variable cost I don't think would be great. Kind of want to go for a lowish fixed cost so that this is actually always a priority thing to do. Required resources is pretty straightforward. It definitely needs the legs, and we want to make sure we're using the torso as well. So that's good. In terms of then, oops, and that actually should have been GOAP action FSM. So that's going to change things a little bit. Remove all of those ones and let it implement the things that I need. So that's better. So populating the supported goal types, always a straightforward thing. Supported goal types is a new system type, and we just do type of and our GOAP goal chase, like that. So all we need to really do then is configuring the FSM. Now this one actually has to work a little bit differently to what we've done before. So we need to be continually refreshing our move location and continually updating that. So what I'm actually going to do is I'm going to set up here a thing of child states, which is a new list of ISM state, like that. And then that is going to get added to it a new and a calculate move location. Now we need to provide obviously the navigation interface. We need our search range, which we've got that. And we need to also provide, we could provide a custom name. We're not going to for now. We do need to give it a function for it being able to figure out the location. So we're going to have a get target location. Now, unsurprisingly, that get target location gonna look basically the same as this. So we can bring that over. Doing the exact same logic, so that's good. So that's one of the child states we add. We also add a child state for doing our actual move to. Again, providing the navigation interface, providing our stopping distance. And what I'm going to do is that stopping distance actually increase that for the chasing. Now, I'm going to, for this, then when we add this in, our linked state machine, because I want these to be continually running and updating. So I'm going to add a state, and this is where we'll use our parallel state. So we use our parallel state, we give it the child states, and we just then do our add default transitions. So a lot of this is going to be very similar to what we've done before. Now the thing is though, these calculate move and move to are currently designed to essentially only work for a one-off case. Like, I've found a location, I'm going to find the navigable spot and move towards it. They're not designed around being able to continually repath. So we actually do need to make some modifications to these. So I'm going to do that here, and what I'm going to do is give an option here for bool and a in continuous mode, which I'll default to false. So this is going to exist for our calculate location and for our move to. So we follow the same pattern for both of those, and they do both need to make use of this. So we'll have a bool continuous mode, and we'll put that in both of these, like that. We'll store that, so that's good. I'll actually put that line below, just so I'm being consistent with the ordering. I like to try and make sure that that's properly consistent. Do the same. This one's actually all good. The continuous, like that. So that's good. So in terms of with the calculate move location, that one, not too much needs to actually change. The main thing that needs to change here is previously what would happen is once we found a location, we would just return finished. So what I actually want to do is say if it is continuous mode, then we just say running rather than finished. So it can continually go and actually refresh the logic. And then in the onTick internal, if it is in continuous mode, then what I will do is I'll do a return, and we just do the onEnter internal again. So continuous mode, whenever it ticks, it will go and refresh, find the nearest navigable location. Now we could do some filtering there if it only goes and refreshes it if the location has moved more than a certain threshold. So that's a thing we could do to make it a little bit more efficient, so it's not redoing it every single frame. So we could have last search location, and what I would do is our last search location would get populated. I think we would go for populating it only when it's been successful. So that's going to be the move location. Then what I could do here is, okay, well, let's retrieve again. Yes, and I'll take most of this logic because largely we're using all of it. So we'd get the search location again. If that did fail, we should just fail out. That's sensible. What I could then say is, okay, well, if the distance here is sort of changed enough, so if move location minus last search location, and that's something where I might actually rename that because, well, no, that's actually not an unreasonable name for it. It does go and snap it down here, which I think is fine. So I think it's okay. There is further things we could do, but I think that's reasonable rather than creating an extra variable just for the sake of this. So if that square magnitude has changed by more than some threshold, so what I could do is have a threshold that could also be configured. So distance, recalculate threshold. We might make that reasonably small. So we could allow overriding of that as well. So we could have float in recalculate threshold. It's 0.1f. And what I'll do is store recalculate threshold squared. And then it's going to be that multiplied by that. So we store the square of it. Just makes it a little bit easier, saves us having to do the maths later on. So if it's greater than or equal to recalculate threshold squared, then we could just go and run our onEnter internal. Now it would mean that it redoes all of this logic, which is a little bit more than we ideally want it to redo. So that's something where what I could actually do is just take this chunk of the logic, bring that here. So if it's greater than the recalculate one, then that looks good. And here we just return running. So the idea is if we've moved far enough, we'll recalculate. So that looks good. Now that means that in our chase one, what we can do here is we can say true, because that is in continuous mode. Same thing for our move to. And the move to is going to have fairly similar logic. So what we would do for our move to one is we're already storing if it's in the continuous mode. Now the move to already, when it actually enters, just goes to running, so there's not further stuff we need to do there. It's more this tick internal where we need to actually do additional logic. So what I would do is I would say, okay, look for changes to the destination. So this will have a similar thing of it's going to store the last destination. And what I would do is, so here where we end up being up and running, actually, yeah, I think there's a few different ways we could go about approaching when we set that last destination. But I think given we're only going to be checking it in tick, I think the safest option is that we actually set it here, like that. Then what I would do is in our tick, I want to check, okay, well, vector 3, current destination is common core, something like that. And I'm going to check, firstly, are we in continuous mode? So it's only going to look if we're in continuous mode. If we are, then we get the current destination. And we would say F Blackboard, and we will try and get the move to location. So we want to try and retrieve that. So our current destination, and we provide all of the usual logic that we would. So we don't actually need to do an if for that, because that we can assume should be valid. But what I would say is if current destination is the invalid position, we should actually just return it has failed. So if that's cleared, been removed in any way, we shouldn't actually try and move. we should have our same sort of threshold thing. So it's not really a recalculate threshold in this case. I would call this more a repath threshold. So we'd have float in repath threshold, and I'll default that to same value. Repath threshold squared is that. So that's good. Means we can do similar logic down here of, okay, well, if our current destination has changed, so if our current destination minus our last destination, if the square magnitude of that is greater than or equal to our repath threshold squared, then what we would do is we would firstly update the last destination, and then we would say, well, if our navigation and we do a set move location of that current destination. Actually, the mover, we need that. So we have self, current destination, and our stopping distance. If that's successful, then we just return running. So have we moved more than a threshold? So that's good. That gives us a way of actually just having it be able to do the repathing and have these run in a continuous mode. So that parallel one will essentially just keep on running the whole time. So that's good. That gives us all of the logic we need in our nav mesh move in terms of with then the rest of the stuff that we need for it. Well, the other thing that we do need is we actually need to know our target because we don't have our target being populated currently. What I can do though is I can attach these scripts onto this. So I can give this the chase goal and I can give it the chase action. And we can apply that to the base one. So that's good. So our awareness system side of things does already have stuff for indicating that a target has actually changed. So what I can do to populate the Blackboard is similar to how we have these hooks for the navigation functions. What I can do is I can have public void set detected target. Now later on, after this series, I do want to go and overhaul the sensor interface for this. I didn't want to do that for this video because it was going to be just too many changes all at once. But there is going to be a later change that I do is overhauling this sensor interface. So this gets the target. And then what I can do is firstly, I want to get the current target. So I have the current target. So I would do a linked Blackboard. Actually, that is just, what is our Blackboard called? Current Blackboard. So we just try to get, and we're looking for common core and names and our target game object. We out to that target and the default is just null. So that's good. So we want to look first if we're changing targets. So if we're changing targets. So if the current target is not null and the current awareness target or current target is not equal to the new one that's been supplied. So essentially if we already had a target and we are changing to another target. So that's what we're looking for with this. The reason for that is there is going to be some stuff when we get to looking at things that we will actually need to be doing. It's not something that we need to do at the moment though. And actually this, we don't want to get the target game object. This is where what we're going to do is if we go to where we have those names defined, we're actually going to create another one. And this is something where I want to be making sure I'm splitting these things up quite a bit because it actually is going to make life a lot easier. So what I will have is awareness best target. Best target dot game object. So intentionally, the target game object is kind of like the final outcome rather than being sort of the direct thing that gets set. This is something that I found during the testing and development of this, that there was lots of things that could be feeding in potential game objects for stuff, and it worked well of having those all in separate entries in the Blackboard, so that then what I could do is pick and choose from them, and the actual target game object became the result of that selection. So splitting the two up worked really well, I found. So that's why I'm doing this sort of additional extra bit of logic. So what I will also do is then down here actually retrieve our current target. So our current Blackboard. So we would do a try get and our names and current target, well, a target game object. So like that. So we're wanting to firstly check if our current target is the awareness target. So if current target is equal to the awareness target. Now the reason I want to check this is because if it is, and I am changing what my best target is, then I actually want to clear that target game object. The main purpose for that is that's going to force a selection to then happen of what I should actually be treating as my target. So I want to do a set and a common core names target game object, and as we've done before, game object null. So that's just to intentionally clear it out. It makes it a little bit more reliable for then working with stuff. Then our current Blackboard, we're going to set, and what I'm going to set is our common core names awareness best target to in target, like that. So that's good. We've got the awareness target, things like of that being actually set and populated. Now, one thing we do need to make sure that we do is with our setup here in terms of goal for chasing, what we actually want to do is the chase goal. We were using our target game object. We actually want to give priority for game object wise to the best target one here. So that's one thing we want to change with the goal. That's similar in the action when we are going and searching for stuff. What we want to do is we want to make sure that we are searching for that awareness best target. So we want to use the awareness one. Now, when we have successfully sort of found one, as in like if this case, where we get a target location. What I want to do is, as well as setting that target location and returning that, I actually want to, with the linked Blackboard, set Common Core names and the target game object at this stage, just because that is actually our focus target. So if Chase is running and we are focusing on this particular object, then I want to mark that as being our target. Similarly, if we're just going based on position, we just use the position one. I would actually do, as we've done in other ones, set this to null. So game object null, like that, just so that it's clear what we're actually focusing on. So, okay, let's rig this up. We need to connect our onBest target changed up to our GOAP brain wrapper. And we've got our set detected target. We're going to apply all of those overrides. And then let's run this. So we can see it's got wander, idle, and chase behaviors. We can see the chase behavior is currently very low priority. And it hasn't actually sort of seen us yet. Now it has seen us. And so now it's going to continually be running after us until it gets nearby. And then it's still going to stay in chase because we're nearby. Now we can see that it's not properly registering that we have moved. It now has updated. But we saw that once it had stopped, it then is not going and properly refreshing for actually moving. We can see the navigation move to location is updating, but the actual rest of the logic is not updating. So that's something where what we want to do is take a look at what should be happening is move to here should be in continuous mode. And we should be able to tell pretty easily if it is. So move to doesn't seem like it's necessarily being run. We're not seeing tick being hit. If we take a look at our calculate location, that is getting hit, and that is in continuous mode. We can see that it hasn't refreshed yet, but if I run this and then move, it does refresh. So we can see that has gone and done another search for that move location, and then that should be getting updated. So it's updating the move location correctly, and it's going to be returning running, but we're not seeing our move to regularly ticking. So what that may be is that may actually be a problem with our compound action here, well, our parallel action. So if we go and take a look at our parallel and see what the logic is for it, so it should be trying to run all of the states. So that's the on enter, and we have our on tick. So we can see it does have all of the child states, and we can see move to is currently saying its status is finished. And if we take a look and see, okay, well, tick is running here, and tick only runs the tick internal if it actually says that it is finished. So the problem that's actually happening is if we go to our move to, then what we should be doing is our move to, if we are in continuous mode, so be continuous mode, if it's in continuous, we just actually return running rather than finished. What we can now do is, and if we run it, and we'll let the AI catch us, and then if I move away, they continue pursuing. So that's good. We have our chase behavior up and running. We have that information being properly populated into that, which is great. So with the chase functioning, what I want to get going as the final part is I want to get support for being able to have this look at goal, because that is actually one that kind of pulls together a lot of different things, and some of how I've structured things, in particular with like that set detected target. It's going to make a lot more sense once we have this look at point of interest goal and everything happening. So let's create the goal first. I have a GOAP goal, and this will be look at point of interest. So I'm going to set it up first because there is very little to it. So this is going to be GOAP goal base, like that. And prepare for planning, pretty straightforward. Its priority is always just going to be a fixed one of ambient. So very little to it. That's all there is to the goal for it. The action obviously is going to have a bit more logic. So with the action, what I'm going to do is create a GOAP action, look at point of interest. Now, this is going to be a little bit involved, and there's a few custom states that we actually need to set up associated with this. These will be states that I created the GOAP example layer. Once I've made the interfaces more generic for the sensor system, I'd be able to move stuff like this down to a lower layer, but I don't think it's quite ready for that at this stage. So this is going to be a GOAP action FSM, nuke all of these, and we'll do our implementation. So in terms of with the cost, I'm going to, again, make this just a very low cost, intentionally low cost. So that's good. Required resources. Well, the only thing it really needs is the head. Doesn't need any of the other resources, specifically don't want it to be making use of the other resources. So what I'm then going to do is supported goal types is a new system type, so same as we've done before. And our goal at point of interest. So now we just need to configure the FSM. Now, the FSM is pretty straightforward. It's going to be quite similar to what we were doing with the chase logic in terms of having stuff running in parallel. So what I will again have is child states is a new list of our SM state, like that. We'll do child states add. Now I want a SM state So first thing it needs to do is it needs to be able to select a point of interest. So that's going to be one of the things. It is going to need a bit of a helper function, similar to what we did for some of the other ones. So it's going to have a pick POI function, and that's going to be it. Then there will be another one which will run again in parallel, and this will be look at point of interest, and this is going to have a function that will allow it to set a point of interest. Then all we need to do is what we did with the other ones, linked state machine. We add a parallel of those child states like that, and we add our default transitions. So that's going to have our usual setup with the finished and the failed. So that's good. We need to implement those states, obviously, but I want to set up the wrapper because we're going to do that similar process with the Unity event. Now, this is why with the navigation interface, I hid this away inside the interface and additional logic there. The looking at side of things isn't sophisticated enough to really sort of handle that yet. And so I wanted to just go with this being directly in line in the actions. So this will be a Unity event. And what it's going to do is have a game object and a similar process of a system action where we get a game object. So this is going to be a function to on pick POI. That then we'll have a similar one where this sends out a transform, and this is going to be on set point of interest. Now we need to wrap those, so that's where our pick point of interest function and so forth are going to be set up down here. So we have a game object, pick POI function, and that takes in the querier. Now, in a lot of cases, we're not using this querier. That's okay. It's really me having it there for sort of future support. So point of interest is going to be null. And so that is a game object. Then what I would do is on pick point of interest, and we invoke it with the querier, and then that runs in found POI. So we're doing the same sort of syntax we did for the navigation side to actually go and allow a Unity event to effectively return something. So it's kind of a sneaky little trick, but it works horrifyingly well, which is really handy. We'll have our set point of interest function. That takes in a transform. Actually, this one takes in a game object. And all this needs to do is on set POI function. And what this will do is in POI transform. And we just invoke that. That's pretty good. That's the core of its logic. There's just then these states to actually set up. So the action doesn't need to do much. It just will continually run these in parallel. It's really down to what the actual state and everything does. So let's get these states created. So what I'm going to do is I'm going to create another folder here for states that are very specific to our setup. So we're going to create a state, select POI, and similar to what I did here, we'll also create a lookat one. So we'll create a script for lookat, and then we're going to modify both of these. So let's look at what these need to actually do. There's not too much to them. There's a little bit of logic, but it's not too much. So we have our lookat point of interest one. Sorry, this is not inheriting off of that, inherits off of state base. So constructor-wise, we know that this is going to need to be storing a system func that has 2 game objects. And this is our pick POI function. So then when we go and set our state select POI, we know that this is going to be one of the inputs. We support, as always, our in custom name, like that. We run our base with that. And then in terms of with this, pretty straightforward. So that's the essentials for the constructor. We let it implement these individual ones. Now exit, really easy, nothing we need to do for that. The tick internal, again, nothing we need to do for that. So we're just going to return whatever the current status is. All of the logic actually just sits in the enter. That's when we do the decision making. So that's kind of how I structured a lot of stuff with this. It does front load a fair bit of logic in the on enter quite intentionally. So, okay, well, if our pick point of interest function is null, then that's actually pretty easy. What I would do is in Blackboard, and we're going to set. Now, we have not set up our additional names for this. So I'm going to create another entry here, and this is going to be our lookat game object. What we will do is we will set our common core constants, names, and our lookat game object to game object null like that, and we'll return failed. So if we don't have a function to let us actually pick one, we immediately just fail out. The default is going to be that we finished, but what I then want to do is I want to run that function and try and actually manage to select something. So firstly, I need to grab self. So we get our owner from the Blackboard, and then our point of interest. Well, we have a pick point of interest function like that. So attempt to pick. Now what I would then do is if that's null, well again, we fail out. Exact same way. We make sure that there is no point of interest object set. We return failed. Otherwise, what we do is actually pretty easy. We set, unsurprisingly, our common core names and our lookat game object, and we set it to POI. So that's actually all it needs to do for selecting the point of interest. So that's pretty straightforward. The next one we need to set up and running, and it's also going to be pretty straightforward, is our lookat. So we know that this needs to implement state base. We know that this is going to be running a system.action that takes a game object, and this is going to be our set look target function. We'll set look target. So that's good. So we can set our constructor up. We have to duplicate this. Sometimes the autocorrect does IntelliSense does a pretty good job of kicking in and realizing, hey, I can just fill this in. Other times, not so good. Good. And set look target like that. So far, so good. Now, in terms of what we need to be doing, exit, again, doesn't need to do anything. Tick is just going to return the current status. So very, very minimal. And then enter is where we have the majority of the logic. Now, unsurprisingly, if our set look target function is null, we immediately fail out. And by default, we'll finish. Actually, no, by default, it will stay as running, not finished. What we would then be doing, which actually the select POI, we actually should do the same thing there for it. It should be set to running. So, okay, what we would then be doing here is we want to try and retrieve our point of interest. So we would be saying in Blackboard, we do a try get, common core, names, and our lookat game object, and we would default that to null. Unsurprisingly, if the point of interest is null, we return failed. Otherwise, what we do is we would do our set look target function and invoke that. So very straightforward in terms of what it's needing to do. There's not really too much in the way of logic to it. So that's good. It will continually run that set look target. So, okay, we can link that up to the script here. I'm actually going to put this though onto, and I'll bring in the base one, because the lookat more makes sense being there on all of them. So the awareness system, I will actually do the hooking up of that in the base as well, just because that does actually make sense to be in the base one. And then I'm going to bring in our GOAP goal for lookat and our GOAP action for looking at. Now, there's obviously functions here that I don't have that I need to bind to and get set up. So those, in terms of being able to select a suitable point of interest, that's actually something where that's going to come from the brain wrapper. So that makes the most sense as far as location to actually set that up. Don't know why second Visual Studio was loading, but for whatever reason, it was. So we can get rid of some of these ones that we are not needing to do any more with at the moment. Don't need the navigation interface, or the base goal, or the base brain. So the brain wrapper. This has already got some stuff here for setting the detected target. Well, Similar to what we were doing here with clearing out stuff, that also applies actually to the lookout target that we're trying to retrieve. So this I would change to look at target. And what we're going to do is that would be look at game object. Just so that if what we're doing essentially is clear the look at target if it matches the old awareness target. And then here, this is kind of clearing the focus move target if it matches the old one. So just handy to make sure that we're properly clearing that out. Then we know we need our interfaces for being able to select a suitable point of interest. So we need a public void pick suitable point of interest. And we know from what we set up with that takes in the querier, and that was also getting a system action with a game object, and that was our callback function. So we know we've got the select logic. We also know we need to be able to set the target. So again, I'm going to link these up on this base one. So for the picking of a point of interest, that's going to go to the GOAP brain wrapper. And what we connect to is pick suitable POI. Now, setting the point of interest, that's actually one where what I would do for that is, while I'll initially just drag in the brain wrapper, it's actually, and I'm trying to remember where I put this on. I think it is on the character. Yes, the simple AI character, so set look target. So those interfaces are hooked up. We can apply all of those. So that should mean that our look at here is properly populated for that one, which it is. Means I can get rid of this other one, which is good. So that's looking good so far. Just want to make sure I save everything. Then what I want to do is, the lookout logic is already implemented. It's now down to this, how do we choose a suitable point of interest? And this is going to be one that we do revisit sort of a couple of times because there is going to be additional stuff we add to this. So our awareness target is one of the ones that we want to actually check for first. So if we have an awareness target, and we want a way of validating these points of interest as well. So what I'm going to do is have a bool is POI valid. And essentially, initially for now, all it's going to be is f in POI be valid as long as it's not equal to null. But there might be further logic we want to add later. So, okay, priority we want to give first to this awareness target because this is potentially something that is hostile to us. So if we have an awareness target, then it takes priority and we return. So first priority is our awareness target. So we always pick it first. So that's good. So that we can make use of. The next priority we would then give would be to if we've just got a general sort of focus target. So that would be our next priority one. So we would say, okay, second priority is our current focus target. So F, and this should be wrapped with a is POI valid, just so if we add in additional logic later, because we might want to check angles, things like that. So F POI is valid for our current target. Then we do the same sort of logic, current target, and return. So the idea is really just to make it that we can carefully sort of switch between which ones, and we have a level of prioritization essentially that we're enforcing here. And then the final priority is our current look target. I'm actually going to just change this to next. That's good. So similar logic. Current look at target is null. Try and retrieve that. So do our try get, common core, names, and our target, and this would be our look at game object. Same sort of setup. Again, F is POI valid for that current look target. We run our callback. So we'll set that and we return. Otherwise, we would run this with null being provided. So we clear it out. So what I should find is when the AI is chasing me, I should see that the look system is running and that it has me as its actual sort of focus target. And I don't know if I've got what I've got in terms of debugging for that. We will find out in a moment. I know there is some stuff there, so we can actually draw the look direction. So we'll be able to see that in the display here. So I can see where it is looking. And yeah, the AI has a couple of issues with moving around the things. And what I should find is that the head, now if we take a look, we'll bring the game view up here. We can see we do have the look at target is the first person player. Now it's not going to necessarily be offsetting that brilliantly. And if we do take a look and see, that looks kind of where the first person player is, but it is a little, like it is offset. So that looks like something might be going a little bit wrong there. So what we would do is we know that a lot of this logic should be set up pretty much right. It should be running this set look target function. So we can just check and see what's happening there. So we can see that's not showing up, but it's actually continually running. So that's something that is obviously a little bit of a problem. What we would check is, okay, well, is select point of interest running? And actually, so what we've done is our tick is going to be running, but it's not refreshing it. So that's a very straightforward fix. What we should be doing here then is we can get rid of those breakpoints. We should be running on enter internal and provide the Blackboard. select point of interest should actually be doing a similar sort of thing where it is continually running that. That is something where we may want to run it at an interval or be periodically checking if this Blackboard key has changed. But that's for now. I'm going to run on enter internal with the Blackboard. So with those issues fixed so that this is continually running, even if we run this up, we'll find that it's still not perfect. And once we get their attention, yo, now they'll be chasing me. And the issue that it's hitting into, and I'll see when I move to the side and that, it is going to be refreshing, but the problem that it will have is that it is going to be hitting the limits. So we actually have, and if I go to our haven't actually had it recently open. This is probably going to be on our simple AI character. Actually, if we go to the base AI, so we've got our look at logic, and this happens in late update. What we have is we have limits here for the maximum pitch and yaw that it's able to look, and it's going to be hitting outside of those. So I'm actually going to make a slight change to how this works, because this made it so that if any of them was out, it just nuked it. What I will instead do is if the pitch is out, but the yaw is fine, then actually still allow it to work. So we're going to change the logic around here a little bit. I think if the pitch is out, then it's okay to just still follow the yaw. That's going to work well. And it's actually going to hide a lot of the issue here. So the minor change that I will make, if yaw is invalid, or if yaw is valid and pitch and everything is valid, we just set both. Otherwise, if, and I might actually put this here, valid, just because I'm going to be checking it a couple of times. So if yaw is valid, but the pitch is invalid. So, and this code is still following the old coding standard. It is something where I will be updating this as I go and make other changes to it. So if yaw is valid and pitch is not valid, then what I will do is desired yaw delta is yaw delta, but the desired pitch delta is 0. Otherwise, we just return to looking forwards. So it just means that if we can't look at it, won't go and look at the player's feet all the time. So let's test this out. I might just move the AI to a position where they are more likely to run into us early on. And we'll actually rotate the player around as well, just because that would make things a little bit easier. Cool. So I should find, so they're now looking at me, and when I move, they stay looking at me. So until we get around to fixing up the interface there for the look at, this gives at least a good workaround for that. So we have chase behaviors up and running. We have logic going for looking at points of interest, and those are working. We've got a couple of the prefab variants now set up. There'll be further ones that we add for the individual scenes. This is it in terms of behaviors for the first person scene. And then in the following couple of videos, be looking at getting the behaviors going for the other scenes. Folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out. It's really appreciated. If you are looking for the code for the project, you will find 3 links in the description below. The first is to the code as it was at the beginning of the video. The second is the code as it is now at the end of the video. And the final is a link to the completed Unity package that you can be using for the project. So all of those are available there for you to use. If you have any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time,